हेलो स्टूडेंट्स, गुड मॉर्निंग। आप सबको मेरे यूट्यूब चैनल पर स्वागत है। इस क्लास में हमने फर्स्ट ईयर के नया साल का नया चैप्टर हम स्टार्ट करने जा रहे हैं। ऑलरेडी स्टार्ट किया है। उसका एक टॉपिक है डायमेंशन एनालिसिस। डायमेंशन एनालिसिस फर्स्ट चैप्टर का यूनिट एंड मेजरमेंट्स में का एक टॉपिक है। न्यूमेरिकल्स जो बुक्स में एनसीईआरटी के और पीवाईक्यूज के जो भी क्वेश्चन है पूरे कवर कर लेंगे, जो भी छोड़ेंगे नहीं आज की क्लास में, ठीक है, जो भी इंपॉर्टेंट है, ठीक है, डायमेंशनल एनालिसिस बेस्ड। ओके, चलिए। तो डायमेंशनल एनालिसिस टॉपिक क्या बताता है? टॉपिक क्या बताता है? डायमेंशनल एनालिसिस। ये नाम क्या बताता है? ठीक है, डायमेंशन का मतलब क्या है? मैग्नीट्यूड्स ऑफ डिफरेंट फिजिकल क्वांटिटीज। मैग्नीट्यूड्स ऑफ different physical quantities which are present in the one of the derived physical quantities. Okay, so that type of analysis is called dimensional analysis. Analysis means what? Sorting out. Okay, analysis means sorting out. So here dimension analysis is very helpful topic in science, especially in mathematical equations. When we are dealing with the mathematical equation, that time this topic is very important. When if we are not aware of the complete concept of that equations, for example, any one equation is there, means its physical quantities we are looking there, but its unit we don't know. That time we can write its unit correctly by using dimensional analysis, and we can convert one system of the data to other system with the help of the dimensional analysis. And whether that given equation is correct or not, that also we can check by using dimensional analysis. Okay, so example I'm taking here. See, dimensional analysis is nothing but what? It is a way of expressing or writing the equations, physical quantity relations in terms of the fundamental quantities. Okay, in terms of the fundamental quantities. I am taking one example here. That is a area. Area geometrical formula is what? Length into breadth. Okay, length into breadth, or pi r square. Okay, so like that. Or if it is a square, then we can write a side square. Okay, so in all you can see this length measured in length only, this breadth also measured with the length instrument only, meter scale, and this is a constant. Pi is what? Pi is a constant. And here r is what? It is a geometrical quantity that also measured in length only. Okay, here length, here also length. And here side means what? Square. If you take a square, all sides are equal and its area is given by side square. So side square, if I take a side as a square, it means what? You see here also area represents how it is. Length into length, how many times length are there? 2 times. That is represented by power 2. This power indicating that physical quantity present there 2 times in multiplication form. Okay, and here also you see there length, see square is there, so length square, and here area square. This area also A means side also measured in length only, therefore length square. See, area represented in length form with the power 2, that power indicating, that power showing us that that physical quantity is present in 2 times in multiplicative form. In multiplicative form, if you take a standard form of the dimension analysis for the area, see, if I write area A, its dimension formula, correct writing dimension formula is like this: in square bracket, whatever physical quantity you are having in that equation, you write in all physical quantities in square bracket, and in RHS side, whatever quantities are there, but dimension analysis, right, we should write in all quantities: mass, length, time. Mass, length, time. Even though any physical quantities are not present in that one, that you write with like this. See, here mass is not there, therefore you write mass power 0. Mass power 0. And length is 2 times, write power 2. And time is not there, time write here 0. This is the standard form of the writing the dimensional analysis. This is the standard form of the writing the dimensional analysis. Are you looking clearly? Okay, then one more you take. This also we can write: mass not there, write with the power 0. Length is there 2 times, time is not there, write with this one, and this also same. Okay, this also same. So from this one, what you understood? From this one, what you understood? You can write like this: any derived physical quantity in terms of the fundamental quantities mass, length, time. If you take one more example, that is speed. What is that? Speed v. Okay, speed is a scalar quantity, therefore speed equal to what? Distance by time. Distance by time. Distance by time. So fundamental representation of these physical quantities, what? Distance L, meter. Okay, and time 1t. This is the physical quantity which derived quantity, the speed represented in terms of the physical quantity like this. Okay, length by time. Then how to write dimension form for that? See, right here in the square bracket, v equal to, see here, see, length is there once, it is power, right, 1, and time only once, right, is power. But standard form of writing is what? Writing all the fundamental 3 quantities in square bracket. That is the way of representing the dimensional form to any given formula. Okay, then how to write this one? Here mass is not there. Then you write power 0. L is once, write 1. T is 1, but in denominator, if you take in numerator, it becomes minus. Power. So this is a way of writing the dimensional form for speed. Okay. Similarly, you can take one more example, that is a force. Force equal to what? Force equal to mass into acceleration. If you write that in terms of the dimension formula, that is formula, if you write in square bracket to represent in dimension form. So here mass is once, you write directly once. Okay, here its unit is what? Meter per second. Meter per second square. Okay, meter means what? Length. Only once. Per second square. Per means what? In denominator. Time is in denominator in acceleration. Okay, if you take it up, it becomes minus 2. So completely writing the dimension form for force is m once, it is there. M is once, mass is only once, one time. Only once, and length is once, and time is twice. But in denominator, if you take minus power, you should take minus power. So this is the way of writing the any physical quantity we can write. In terms of the dimensional form. Okay, and this will give the clear concept of the physical quantities which are present there in that derived quantity and how many times they are present. That also gives the clear concept. Okay, understood clearly? I think you understood this one. So in books, so many formulas are there, but for this, what we should remember to write the dimension formula, what we should write, we should remember. We should remember that equation must be known. Otherwise, it is unable to write the dimension formula correctly. Okay, okay, beta. Thank you. So next, continue numerical.